Hi, I'm Anna, and I came up with a way to integrate solar energy with existing bionic prosthetics. So, did you guys know that there are 1,285,000 people living with limb loss in the United States? Well, I didn't know this either when I walked into Walter Reed Military Hospital this summer. What I did end up learning is that there are a lot of difficulties amputees struggle with on a daily basis that we know nothing about. One of their unseen struggles is that the prosthetic feels very heavy to them. One of the reasons for this is that prosthetics have very large batteries that are used to power all the motions that the hand does. So from this, my inspiration arose. So I first started searching, how can I decrease the weight of the prosthetic? Well, and then I came across one of these facts, that the battery life of the prosthetic lasts about 8 to 10 hours. So I wanted to figure out a way to make this greater. I wanted to figure out a way to improve the quality of life of amputees so that they can forget about having to charge their prosthetic every night or having to bring spare batteries in order to make their hand last a little longer. So here are the goals of my project. My first and foremost goal was to increase the battery life of the prosthetic. I needed to do this because then it would allow amputees to go on a camping trip or to be able to expand prosthetics to third world countries where electricity is not as accessible. And then I also needed the hand to move. It needed to open and close because if not, then there's no reason for a prosthetic. And then this is the most important one. I needed to improve the quality of life of the amputees because at the end of the day, we're trying to make their life as easy as it can be. So I began my project by researching and finding a 3D online file of a prosthetic hand. It was called the Limitless Arm, which was created by UCF Army. I used this as the foundation of my project, which I then remodeled and added different components in order to reach my specific goals. And you will see these modifications throughout the presentation. And another reason why this file was the best one was because you can reshare it back to the community. And I thought this was the most important because if I want to improve the life of the amputees, I want to be able to share my ideas with the rest. So my first step was to construct the hand. My first task with this was to 3D print all the portions of the hand. As you can see, right here, these are all the parts that I needed to print out of the hand with a 3D printer in the makerspace. So this was a pretty easy task until I got to the flexible joints. So the flexible joints is what is going right here in between each finger. At first I tried printing them with the MakerBot, but the flexible material had issues because it wasn't printing out as it should. So then I found a 3D Hub, which is pretty much a company that prints out any 3D file you send them. So once I got those, I put the hand together, and my next step was to thread it. The reason why I threaded it is because you need to create tension in order to open and close the hand. So if you think of those puppets that have strings, you pull that puppet string, and it makes the hand go one way or another. So that's pretty much the idea to it. So then I integrated the electrical components. So this took up the bulk of my time for the project. So at first I had to create the circuit schematics. So you see this right over here. So I had to be able to figure out which connections I needed to make between which component. So as you can see here, I added this component right here. It's called the Sunny Buddy. So what it basically does is that it transforms the solar output of the solar panels right here, and it creates it into energy that the battery can then use. Right here is the Arduino. This is pretty much the brain of the circuit. So it's going to transform the signal that the muscle sensor sends, and it makes it something that the motor can then read and understand. So once I finished that schematic, I actually started to solder. And for those of you who don't know, soldering is pretty much melting metal and then connecting two wires together. So this is going to allow for the for the current to go through. And at first, my first try for this, it didn't work. I accidentally connected two things that ended up short-circuiting my system, so current is going through. So I had a little freak out moment, but then I reached out to an individual that works with this systems, and he helped me, and I learned how to first simplify the circuit, and then also figure out where my issue was. So the second time was the charm, and it ended up working out, and then my last step was uploading the edited Arduino code. So this code is pretty much programming. If I touch this button right here, it's going to tell the motor to move. So then I put it all together. So what I had to do is I connected the battery to their respective spaces, and then I also connected the solar cells. And then after this, I had to thread, right here you can see, I had to thread the cords from the hand to the motor. This took me a little bit of a while because I needed to make the spacing perfect so that the strings were taut, so that when the motor does move, it does create tension, which will then close the hand. And then I attached all the electrical boxes to this board for rapid prototyping so that I could start testing. So my testing consisted of me figuring out how the battery life of the muscle sensor would change with and without the solar cells. So my control group is right over here. It's the one without the solar cells. And then my solar cell group is right over here. It has the solar cells. So here's a little sneak peek of how my testing worked. So basically what I'm doing is I'm trying to discharge the muscle sensor over an hour. So I'm trying to make the muscle sensor work continuously over an hour by sending a signal to the motor, which is what you saw the hand moved. The reason why I have that green little thing moving around is that I needed to figure out a way to automate my testing because I don't want to sit there for an hour touching the muscle sensor every couple of seconds. So I tested for an hour for each control group, and I did 5 trials for each. So in total, I did 5 for the control group and 5 for the solar cell group. So my results here show that for the control group, right here, which is the one without solar cells, it discharged at a steady rate of 0.02 volts. So in other words, as I was using the muscle sensor, voltage is decreased in the battery. So here it shows that it will go down, and 5 data points were enough to then extrapolate the data. And then right here you can see that by adding solar cells, the voltage stayed at 4.13 volts. So what does all this mean? So without solar cells, the battery would discharge in 68 hours. But when I did add solar cells, it remained at 4.13 volts, which means that if it's in continuous sunlight, the battery won't discharge and you can use it as long as you want. So my conclusions. First of all, I was able to increase the battery life. So my proof of concept worked, that if I add solar cells, I can make the prosthetic last as long as I want to. And then the hand didn't move, as you can see in the video. And lastly, the amputee's life was improved by being able to do this. So my reflection. During the STEM capstone, there was a lot of ups and downs for sure, but I was able to learn how to solder, which would be a great skill for college and just any other engineering classes. I was able to learn how to manage my time because we had to assign ourselves homework every single week during the second trimester in order to finish our project. I also had to learn how to create problem solving. Like you could see with that little bug that went around, that was something that I just thought of in order for me to not have to sit there. And also I learned how to network. I learned how to email other teachers or people that are really that are just professionals in their field. And I also learned how to do research that is reliable and would help me in the future. So I want to thank Ms. Darling, Mr. Kojal, Ms. Rathman, and also my parents for everything during this project. Thank you. Does anyone have any questions? In my prototype, it's my solar cells are just basically on a board, but if I were to continue, I would 3D print out the board, and those would be like attached on like the top of the, and since they're flexible and thin, it would be able to roll to that shape.
Do you plan on like continuing this project when you graduate, or like making this like an actual product, or how do you
Well, I'm planning to study biomedical engineering, so hopefully I can do do this project in college as well. So. Great question. I don't know, but the part of the hand that you see is plastic and it's rubber, so it has no, none of the cables going to it, so that shouldn't be a problem. It's just how much can the plastic withstand the water? But that's a good thing to test next. Anything else? All right, thank you.